Hello and welcome to Pharmacology 104, Understanding How Drugs Work. This lecture is structured a little bit differently. We will be going over different uh, test questions and answers, and the idea is that by testing yourself, you can get a better understanding of the concepts that we previously talked about. So let's look at our first question. So you have these two wonderful patients here. You have Kate and you have Johnny. And you have a dose of the drug that was given to both of them. So Kate was given 500 milligrams and Johnny was given 20 milligrams. Now we have their initial serum concentrations of the drug. So Kate measured up at 40 milligrams per liter and Johnny was at 1.5 milligrams per liter. So try and figure out which one of these patients will actually have a greater volume of distribution. So now this is a good time to pause the lecture. I'm going to move to the solution, but you're welcome to work on it yourself and then listen to me going over the explanation. So we remember that volume of distribution is a theoretical volume variable. It doesn't actually refer to a specific volume of any compartment like an arm or a leg. And we can calculate the volume of distribution based on the formula. All we need to know is the amount of the drug that was given or the dose and the initial drug concentration that was measured. And we actually have all of that information. So all we have to do is just basic math, plug it in, and see which one of these two patients will have a greater volume of distribution. So let's do that. So Kate volume of distribution, we're going to calculate it like that. So 500 milligrams by 40, that gives us 12.5 liters versus Johnny is going to have a volume of distribution of 13.3 liters. So Johnny wins, even though he was given a smaller dose of the drug and he had a much smaller initial concentration, he actually has a greater volume of distribution. So now let's move forward to the next question. Explain how a 70 kilogram 21-year-old male, and this is our stereotypical 70 kilogram 21-year-old male, can have a volume of distribution for a drug of 600 liters. Well, we already talked about that, so you probably already know the answer to this question. But just to remind you, volume of distribution does not refer to a volume of your leg or volume of your arm. It's basically a theoretical variable, and what it represents is just how much the drug distributes in your body. So if a drug distributes heavily into tissues, for example, digoxin has a volume of distribution 440 liters. It's a very large volume of distribution, and that is because digoxin will bind extensively to the muscle tissue. So therefore, it will have a very great volume of distribution. So that's how that can happen. That's how this is possible. Next question is going to be, for the body fluid compartments below, what you need to do is rank them from the lowest volume to the highest. Again, in a typical 70 kilogram person. And this is going to be extremely easy for you. You probably can do this right away. But if you want to work on it for a minute, that's fine. I'm going to move forward to the solution. So the solution is going to be A. And why does that make sense? So remember that total body water, this is your entire content of water. We can actually calculate that for you. So if a person weighs 70 kilogram and about 60% of their body weight is going to be water, their total body water is going to be 42 liters. So that remember that intracellular fluid is going to be about 2/3 of that, and extracellular fluid is going to be about 1/3 of that. And then out of the extracellular fluid is going to be composed of blood plasma and also interstitial fluid, but plasma makes the smallest point. So it only makes sense that the total body water is going to be the highest volume and the plasma is going to be the lowest. So ideally, you should have eliminated D right away. So next question. The total body clearance is the sum of clearances by the kidneys, liver, and all the other routes of administration. Is this statement true or false? This is really easy. Hopefully you answered true right away. Hopefully you remember this slide that basically shows you that the total clearance is going to be a collection of all the different little clearances by the kidney, by the liver, and other organs as well. So, and next question, for drug X, individual organ clearances have been determined as follows. So you have a renal clearance by the kidneys, you have hepatic clearance, and then you have a pulmonary clearance. How would you describe the clearance of drug X? And please express the final answer in liters per hour. So here we go back to our old trusty formula, and we see that we basically have to add everything up. So when I add up the renal clearance, the hepatic, and the pulmonary clearance, I get an answer of 207.2 milliliters per minute. So I'm going to round that up to 207. Now all I have to do is just basically express that answer in liters per hour. So I have 207 milliliters per minute. I remember that each liter contains 1,000 milliliters, so I can divide my answer by 1,000, and then I remember that for every 1 hour I have 60 minutes. So the milliliters are going to cancel, the minutes are going to cancel, and all I'm left with is a final answer expressed as liters per hour, 12.4 liters per hour. So now let's finish up. We have a couple more questions. Let's say I have this wonderful little doggy, and the doggy is very sick. So I took the doggy to the veterinarian, and the veterinarian actually wrote a prescription for diclofenac. The way that drugs are dosed in animals is different than drugs being dosed in humans. So for this specific little doggy, I know that the doggy weighs 20 kilograms, and the way that a vet would dose it would be 1 milligram per kilogram. So now I know the half-life, it's 2 hours, and then the question is, how much of the drug is going to be present in the body after 2 half-lives? Now this one's a little tricky. I'll let you think about it for a minute, and then we come back to the solution. Okay, so you can pause me here and start working on your solution if you haven't done so, or you can move forward with me to the solution. So, why did I give you a half-life here? Did I have to give you a half-life? Does that information give you anything? No, that information gives you nothing. I just gave it here just to mess with you and put you on a wrong track. So all you need to know is that the dosing is 1 milligram per kilogram and the doggy weighs 20 kilograms. So now I can calculate the total dose of the drug. The total dose that would be given to my doggy would be 20 milligrams. So remember what half-life is. Half-life is the amount that it takes your body to go from the initial concentration of the drug to basically half of that amount. So let's say I had 20 milligrams right here. So after 1 half-life, I would be at 10. And after 2 half-lives, I would be at half of that, which would be 5. Finally, let's move towards our last question. So what are the units of clearance? Hopefully that's intuitive to you, but in case you don't remember, it's going to be expressed as a volume of unit per unit of time, so liter per hour or milliliter per minute. So this concludes the end of the last lecture 104. Thank you so much for your time, and let's move towards the pain management lectures.